Okay, hi, it's 1 o'clock, so we're going to get started. Thank you for joining me today. I'm Kaya Ghosh. I'm a technical applications specialist with FCS Express. And today we're going to be talking about kinetics data analysis in FCS Express 7. This webinar will be recorded and will be placed online on our YouTube channel and on our website, so you can refer to it later if you'd like to refresh your memory when you're trying it out with your own data. We also have Andrea Valle on the line, my colleague, and he will be able to answer your questions that you have during the course of the webinar. So if you do have a question, just type it into the question and answer chat box on the GoToWebinar control panel, and he will get back to you. If it's something very relevant to our workflow, then I'll try to get back to you verbally during the course of the webinar. And if it's off topic or more in depth, we have everyone's email, so we can email you after the webinar to follow up and maybe set up a screen share with you or just point you to the relevant links in our manual. Okay, so definitely feel free to enter those questions in because we're really glad to hear from you during the course of the webinar today. So let's go ahead and get started. Let's just talk a little bit about kinetics in general. So they are useful, kinetics experiments are useful for looking at changes in DNA content, antibody binding, calcium flux over time. Those are just a few common examples. A lot of times during the experiment, a compound like some sort of drug is added to the sample, and then influx, efflux, or probe binding is monitored over time. And so to do a kinetics experiment, of course, you have to be acquiring the time parameter on your cytometer. A lot of cytometers are adding that automatically. If you need to know how to turn that on, just contact your hardware representative for your cytometer and they can help you with that. So FCS Express will allow you to display and analyze your kinetics data in an easy and user-friendly format. And like everything else in FCS Express, as you change the data files of your plots or change your gating, everything updates in your layout in tandem. Okay, so it's live updating, it's very robust. Every element in your layout is talking to every other element, so the stats and the gates, everything will update. Okay, so what's our workflow for today? So we are going to be showing how to create a new parameter based on raw parameters in your data file, because a lot of times you need to create a parameter that's the ratio between two raw parameters like FL1, FL2, or FL1, FL3, and FCS Express will allow you to create that new novel parameter based on your other parameters. And then we will insert a kinetics plot displaying that derived parameter. We'll show how to overlay two kinetics plots. Okay, we're going to show how to draw a gate on the region of interest on the kinetics plot. And then we have a number of kinetics specific statistics that you can show from the right-click pop-up menu of the kinetics plot. Just like you would show 2D statistics from a contour plot or a dot plot, or histogram statistics from a histogram, we can show kinetic statistics from a kinetics plot. And then we'll also show how you can change what you're plotting on the kinetics plot. So I think by default, it's plotting median. I'm going to show you how to change that to mean or percent above threshold. Of course, the threshold is going to be determined by you, the scientist, and I'll show you how to set that up in FCS Express also, and how to plot count, which is useful for quality control in kinetics experiments. Okay, so let's get started. I'm going to start with a new layout. This is not going to be a very long webinar, so even though I'm starting with a new layout, I think you'll be able to get an overview of how to work with kinetics data in a relatively short time. Okay, so here's our new layout. Let's start out by putting in a kinetics plot, which is its own plot type. You can see I'm mousing over it at the top of the ribbon when I'm on the Insert tab. So you have your regular kinds of plots here, histogram, density, color, etc. If you go more towards the right, you'll see kinetics. So we can put in our kinetics plot, and I'm going to navigate to one of the data files that's available in our tutorials sample archive, which you can get online. Okay, so let's look at time on the x-axis, and then we have a number of different parameters that have been acquired with this experiment. Okay, so it doesn't really matter what I choose here because I'm actually going to make a new parameter that's a ratio between two parameters. But for now, why don't I just put Fura red? Okay, so how do we create a parameter that's a ratio between two parameters. In our case, we want to create a ratio between this fluo3 parameter and the Fura red. Okay, so that is going to be here under Tools, Transformations. In older versions of FCS Express, it was under its own button called Parameter Math. Now Parameter Math has been subsumed into the Transformations button. You can get it right here. And it's actually a lot easier to work with parameter math in these later versions of FCS Express than it was in, say, version 4 and earlier versions. Okay, so I'm going to show you how to work with that. Okay, so this window looks the same. It's just within the Transformations umbrella. Okay, so we're going to click on New. And in our case, we're looking at a calcium ratio, calcium flux. Okay, so I'll just call this calcium ratio. And here you can select the parameters that you want to make a ratio of. So I'm going to do flow3, FL1, divided by Fura red. Okay, by the way, if you needed to do something more complicated for your parameter math, you could come here and in the formula, you could just type the names, or rather the numbers of the parameters. So if you wanted to do P1, divided by P3, and then add some arbitrary value, you could do that. I don't need to do that today, but I just wanted to show you that there's that option there if you need it. Basically, any algebraic expression you can put in here. So let's go back to the simple, because we're just doing simple division between flow3 and Fura red, and I'll say OK. And if you try to display that parameter on the axis, you won't see it yet. You have to take this parameter math from the upper pane of the Transformations window and drag and drop it to your plot. And now do you see that the plot title has been updated? Let's see if I can highlight that for you. See, now the plot title says Parameter Math Applied. Okay, so now we can change this y-axis to our calcium ratio. All right, so this is just defaulting to a log scale on the y-axis, which may or may not be fine for your data. In our case, I think it's going to be better if we look at it linear, because things are varying on a more linear scale. So I'm going to change the axes of the y-axis to linear. And I'm also, the data seems to be disappearing because it's most of it is pretty low. So I'm going to change my range to vary between 0 and 1. And so now you can see the data a little bit better. And let me show you that we can actually look at the next data in our data list. So I'm not going to talk about batch processing in detail today, but basically all the files from your data list, maybe I'm going to delete these extraneous files that I don't need. Let's just keep the kinetics files here in my data list. These were added to the data list as soon as I inserted a kinetics plot in a new layout. All the files from the folder are in the data list. So, I could, go backwards and forwards and look at these different plots from the different files, but I'm going to just do this. I'm going to take a shortcut and duplicate this plot, and let's look at the 25 file in this plot at right, because it's kind of nice to look at a couple different plots side by side. So if you see something like this jagged appearance of one of your plots, like we see on this plot on the right, that's occurring because the resolution of the plot, i.e. the binning of the plot, is too high for the amount of data that was collected. So I don't know how often data was collected for this data file, but is probably I'm not exactly sure if it was like every quarter of a second or every 10th of a second or whatever it was, but the resolution of this data file is too low for the resolution of the plot. So let's change the resolution on both of these plots simultaneously. So we'll come to specific options, and I'm going to change this to, I think, 64 by 64. That looks fine. You might even maybe 128 by 128. Okay, so now you see, you can see the data makes a lot more sense visually on this plot on the right. Okay, what else can you do with kinetics plots? Like I mentioned, you can make overlays. I'm gonna just duplicate this plot one more time and have the overlays over here on the right. Okay, so maybe I want to overlay this Kinetics 10 plot on the 25. So this is just a normal overlay procedure, dragging and dropping one plot onto another. Okay, and then you can change these overlay properties as well. So if I go to overlays, maybe I want to make the 25 file be blue, and you can change the thickness of the lines. So most of the things that you can do on a regular histogram, you can change on one of these plots as well, and then you can put in a legend too. So I'm going to put this legend on the bottom. Okay, so that's kind of handy. Sometimes you want to overlay 2 or more files on the same plot, so you can do that in FCS Express just like you would with a regular histogram. Okay, so let's start looking at how to create gates on Kinetics plots. So that's from the same place you would normally look for gating tools in FCS Express. It's here on the gating tab. Since it's a 1D plot, essentially we're going to click on marker and draw a marker here. You can name the gate if you want. I'll just call it region of interest. Okay. If I wanted to, I can show that same gate on this plot on the right. That may or may not make sense for that particular file. So I'm going to undo that, and whoops. I'm going to put in a new gate. So you can get that here from the right-click menu too. Same thing as using the gating tab. Okay, so I'll just call this ROI2. Okay, so now we have a couple of gates on our kinetics plot. So now we can insert some statistics. So remember I mentioned that just like with a 2D plot, where you would right-click on the plot and then you would get statistics here, gate statistics for 2D plot, or you get histogram statistics for a histogram. So for a kinetics plot, you do it the same way. Just right-click on the plot, and under the statistics item in the pop-up menu, click on kinetic statistics. Okay. If I wanted to, I could even put it in for any of the other plots on my layout, like this overlaid plot. In that case, you'll get 2 rows of data corresponding to each overlay. Okay, we can put in an overlay legend here so it's a little bit more clear what row refers to what file. Okay, and there's other statistics you can put in here from the right-click menu, and I want to just take a second to show you the page in our manual. So if you here's the page actually. If you go to our manual, and if you can't quite find it, just look for the word kinetics in the search, or better yet, kinetics statistics. Okay, and so here it's that 4th item, and this is going to explain what all of these statistics are. Okay, most of them are pretty self-explanatory, but you'll get the technical definitions there. Okay, so for instance, maybe I want to look at the start to peak elapsed time. Okay, so it's telling me, let me zoom in because I think these numbers might be a little bit small for your viewing convenience on the webinar. Okay, so it's telling me that it's 77. Look what happens if I change the starting point of this gate. So maybe I want to start the gate where the signal starts to rise, maybe in this valley. Do you see now that the start to peak elapsed time has just decreased to about 37? If I move the right side of the gate, excuse me, it doesn't change because the peak is actually over here near, probably a little bit over 100 on the x-axis, okay? So it's the peak within the gate. So if I move this gate, so it's so narrow that it's not encompassing the peak of the kinetics plot itself, of course, the start to peak elapsed time will decrease, okay? So these are all gate specific. And then you can put in any of these other stats too, area under the curve, anything here that you're interested in, you can put in and display for any of your plots. Okay, so let's talk about, let me actually go back to the summary for a second. So we've done these first 5 items actually. See, we're making a lot of progress. I told you this webinar would be pretty short and sweet because I like to keep it condensed for you. There is a little bit more detail in our manual, which I'll point out to you towards the end. But so let's talk about how to change what you're actually plotting on the kinetics plots, okay? So I'm going to, excuse me. Okay, I've hopped back to my screen with the data that we're working with. So let's zoom out so we have a little bit more room to work. Okay, I'm going to duplicate this plot just because I don't want to mess with the plots that we've made here at the top. Okay, and so how do we change the plotting value? Well, first of all, how do we see what is plotting? We know we're looking at the calcium ratio on the y-axis, but are we looking at the mean for each data point, the median? What exactly are we looking at? So we can find out by going to the overlays under format. Okay, and so you see plotting value, we're now looking at median. Let me highlight this if I can. So if I want to, I can change it to mean. You see that the plot updated automatically on the left. Okay, there's some other options here, geometric mean, percent above threshold, count, etc. So let's actually change this to count because that's useful in some instances. So I'm going to change the plot. I've changed the plotting value to count. You see that the label on the y-axis has automatically changed to number of events per time. I do need to change the range of the y-axis because remember I had set it to 0 to 1, but that's not appropriate for when we're looking at count. So I'm going to just recheck automatic on the range, okay? And this looks a little bit jagged too, so what I'm going to do is reduce the resolution of the plot maybe to 64 or maybe even 32 by 32. And so now you see how useful looking at count is from a QC perspective. So we're looking at the event rate acquisition over time just to determine that it's fairly consistent, which is a useful measure for your quality control. And then this valley here, let me highlight this valley. Whoops. Okay, sorry, my drawing tools have ceased to work, which sometimes happens on my Mac. But basically this valley here near the left side of the peak, I'm going to move my mouse cursor around it. So hopefully you can kind of see what I'm talking about here. Okay, so basically this valley has occurred because most likely the sample was removed and then drug was added and then it was put back. So aside from that, depending on your tolerance for deviation, you can see that it was pretty consistent after putting the sample back, the events per time. Okay, so let's talk about something else we can do with the plotting values that's going to be useful. So for that, I'm going to go to a partially built layout. Okay. Okay, so just take a look at this plot on the right. This is a density plot. And this is actually the same file we were looking at before. We're just looking at it a little bit differently. So in this case, the user is looking at a density plot and they've drawn 2 gates. And one is the baseline gate, that's this blue gate here on the left. And the red gate on the right is the post-treatment gate. So it's after the drug or whatever stimulant or inhibitor was added to the sample. And so what we want to do is define a threshold and then plot the events that are above the threshold for that sample, rather than looking at the entire sample, which would encompass even the events before the drug or the inhibitor was added, okay? So let's restore. Before we do that, I want to show you where the threshold was defined. So that's going to be here under custom tokens. We do have a separate webinar all about tokens, and we have a help topic. I'm going to show you some of how to access the various help resources towards the end of the webinar. But here under custom tokens, the user has ahead of time defined what they want their threshold to be. So they want it to be the Y median for that gate, for the baseline gate, plus 2 times the standard deviation. So they're defining the threshold as the median Y value, calcium ratio value for the baseline gate, the blue gate, plus 2 standard deviations above that. So they're determining, they've defined that any events above that are the events of interest, the events above threshold. Okay, so you can determine what the threshold is for your experiment based on your knowledge of your experimental setup and the biology of your system. Okay, FCS Express doesn't hold you to any particular definition, of course, it's all user defined. Okay, so let's learn how to display those above threshold events on this kinetics plot on the left. Okay, so the first thing I'm going to do is the first thing I'm going to do is gate this appropriately. One second. Okay, so let's gate this on the post-treatment because that's the events we're interested in looking at. Okay, and now we're going to go back to our, whoops, sorry about that. We're going to go back to our plotting values. So that's here under the overlays category. Okay, so we're going to put in percent above threshold, and this plot has updated to a display that doesn't make sense. That's okay. It's only because we haven't told FCS Express what the threshold is. So that's where this field comes into play, this threshold field. Let's see if I can highlight that. Okay, so if you wanted to enter in a free text value there, you certainly could. If you knew it was 500. Or you could click on T for token, and in our case, we're going to select that custom token that I showed you a couple of minutes ago, which is the Y median of the baseline gate plus 2 standard devs above that. Okay, so I'll say insert. All right, and now you see that the plot on the left has updated, and it's showing the percent of the events above threshold at any given time in the experiment. Okay, and so if you wanted to batch through your data files, you could, and get that result from all your data files in an efficient manner. Or if you wanted to look at them side by side in the same layout, you could do that too. So maybe I'm going to look at this Kinetics 8 file that I'm grabbing from my data list and drag and drop it onto this plot below that I just duplicated. Okay, and so you see this one has the 08 file here at the bottom. It has fewer above threshold events than this plot here at the top, which is the Kinetics 10 file. Okay, so it's really very flexible. Hopefully I've convinced you that it's definitely worth using these kinetics features next time you're doing a kinetics experiment and analyzing it in FCS Express. So please get in touch with us if you need help implementing any of this in your layout. So let me just show you how you can get to the help resources. So when you launch FCS Express, this startup screen will pop up if you haven't disabled it, and then you can click on Help in Manual. Just give this a second to open up. Oh, sorry. Okay, so Help in Manual is going to launch a PDF version, which is fine. You can look at the PDF if you want. I actually think it's a little bit easier to look at the browser version of the help, and you can get to that by going to File, Help. I believe Tutorials will take us there. Yep. Okay, great. So that has launched on my other screen. So here it is. And so, you know, like I showed you before, you can just look for kinetics and you'll get a whole bunch of results. There's a step-by-step tutorial here under tutorials, and that's going to show you a lot of what I've already shown you today with the data files that I use today. But you can apply these to your own data files. And another useful thing, which I encourage you all to do, is to contact us if you would like some one-on-one help via screen share or email. So you can just email us at support@denovosoftware.com, or if you can't remember that email address, just click on the little support button here on the startup screen when you launch the software. And then that's going to launch this page in your browser, and you can just click on the email link and you'll be able to email us your question. We have very good support, if I don't say so myself. So we are guaranteed to get back to you within 24 hours, but it's usually much sooner, within a couple of hours or less. And also, I don't want to forget to mention, if you have not downloaded the free demo for FCS Express, just go to denovosoftware.com or Google FCS Express, and then you'll come to our homepage and you can click on free demo here at the top. Okay, and then just click on that button and you can register for a free account on our website, which will bring you to the demo download page. And that's a fully functional 30-day version of the software. And you're able to work with your own files in it. You're not restricted to using our sample files, but you'll also be able to download our tutorial sample data archive if you'd like to try it out with our data. Okay, so thank you so much for your attention today. I'll stay on the line in case there's any questions.